How does BPMN perform on the workflow patterns? How does Camunda perform? Does Camunda conform to the BPMN standard? Hi, my name is Andreas Hense and this video is part of a series on BPMN and workflow patterns. Today I will summarize the findings of the last 43 videos on the control flow patterns. In the first part I will talk about BPMN. In the second part the topic will be Camunda. Right to our first question. How does BPMN perform on the workflow patterns? If we look at the table of all control flow patterns, we can see that 94% of the patterns are supported by BPMN. What does this mean and how did we get this value? For each of the patterns, we did this. If there is a construct in BPMN that directly supports this pattern, we give it the value 1. An example for this is pattern 43, explicit termination. The terminate end event of BPMN directly supports explicit termination. If there is no construct in BPMN that directly supports this pattern, but we could find a viable construction that models our example, and it is true to the pattern, we also give it the value 1. An example for this is pattern 39, critical section. Here we need some underlying logic with global variables, but it does what the pattern requires. If we could model the example, but the resulting BPMN specification is not true to the pattern, or we had some difficulties, then we give it the value 0.5. An example for this is pattern 17, interleaved parallel routing. The concrete example could be modeled, but this does not scale for larger examples. We would have given a pattern the value 0 if it is impossible to find a BPMN model for the example. This has not been the case for any pattern. So what are the main reasons why we did not reach 100% support in BPMN? One is that the workaround for additional work items at runtime in multi-instance tasks is not perfect. The other one has to do with the fact that BPMN does not have Petri-Net Places. This would have been necessary for interleaving, milestones, blocking, etc. So which role do Petri-Net Places play in process modeling? Well, I thought that BPMN event-driven process chains and YAWL were all based on Petri-Nets. On the slide, which I've made using Signavio, by the way, you can see a simple process consisting of tasks A and B in BPMN on the left, and an event-driven process chain in the middle and YAWL on the right. The corresponding Petri-Net is at the bottom. In the event-driven process chain, you can see that hexagonal events correspond to circular Petri-Net places. In BPMN and YAWL, it is possible to omit places between two transitions or tasks. In the Petri-Net, you can see a token in the leftmost place. And when we speak of the token game, we mean that transitions fire and consume and produce tokens according to their incoming and outgoing arcs. We have a token simulation in BPMN, and I had always assumed that this was the token game of Petri-Nets. But much to my surprise, this is not the case. Let's look at an example. So this example is here to show you that BPMN does not have Petri-Net places. If we look at this little process here, we have the start event, and if this were a Petri-Net, this would contain a token, and then either A or B could use the token to be activated, but not both of them. In BPMN, however, this is different. If we look at the token simulation, and we start here, you can see that there are two tokens produced, and this is definitely not the behavior of Petri-Nets. And so there are no real places. If we go here, we continue, then we can execute C twice. Now we come to our second question. How does Camunda perform? Is it the same as BPMN? In Camunda, we have the editor, the token game, and the business process automation itself. The Camunda editor does exactly what we needed here, so there is 100% BPMN conformance in this area. When we look at the percentage in the table, we have a conformance of 80% for the token game and 80% for the Camunda automation. So again the question, where does the difference come from? One is that the merging inclusive gateway is not implemented in Camunda 8.3. The token simulation, however, implements this, although not correctly. The second reason is that the complex gateway is neither implemented in Camunda 8.3 nor in the token game. And the third reason is that the BPMN attributes for the thread merge and thread split are not implemented. I hope you found this series on workflow patterns useful. I would be happy to hear from you in the comments. Thank you for watching.